Today we're going to be looking at logarithmic functions and graphs. So these are the inverses of exponentials. So first, as a reminder, we did this in Algebra 2. When we're looking at logarithmic functions, when you see this, you read it as logarithm base 2 of x. So in between the, word log, you say log, then in between you say base number 2 of x. So in between the log and 2 you say base, in between the 2 and the x you say of. Log base 2 of x. Okay? And that's really just another way of saying the power to which we raise 2 to get x. So for example, y equals 2 to the x is an exponential, right? This is the same as y equals 2 raised to the x. Oops. Y raised 2 to the x. I think I have to do it in one swift swoop. Let's see. Okay. Let's see. Okay. I'm going to have to use that symbol for x because there's no other way to do it right now to my knowledge in this annotator. So if we have y equals 2 to the x, now this is saying the inverse of this is log base 2 of x. Okay, now for example, if you say what is log base 2 of 8, the answer is 3, right? So let's take a look at how we do that. So remember when we have an equation, right? Remember when we have an equation, if we said y equals 2x, why is it doing this? Y equals 2, Okay. This is not working. So if I said y equals 2x plus 1, right? And we said what is, so this is f of x. Sorry guys, it's hard to write with this one. I'm going on top of a PDF, so it's a little bit harder. F of x, y equals. And now if it says find the inverse or find this for inverse, right? Which is still the same thing as y equals. You just write this notation so that you know you're identifying the inverse of this f of x equation, right? We switched x and y, so we'd say x equals 2y plus 1, and then we subtracted 1 and divided by 2, so we had x minus 1 divided by 2 is equal to y. So that's the inverse. If 2x plus 1 is the original, x minus 1 over 2 would be the inverse equation. So that's why we'd write inverse notation, x minus all over 2. Okay? Now with logs, if you had y equals log base a of x, the inverse of that, right? If I switch a, right, take that back. If I switch x and y, we would end up getting this, because logarithm to exponential form, the a goes under the y, so you have a to the y, the log goes away, and you have x. So a to the y equals x is the inverse of log base. No, I'm sorry, what the heck am I saying? Log base a of x equals y is the same as x equals a to the y. That's just a different way to do it if you want to write it in exponential form. So these are equivalent: exponential form, logarithmic form. Okay, so we haven't technically found the inverse yet. Find each of the following logarithms. So there's two methods. You can do, it's called change of base, or you can do it without a calculator. So one way of doing this, if you're trying to evaluate any number, right, you can say log base 10 of 10,000 equals what value? And just like we saw above, you can turn to exponential form, and you're essentially saying 1,000 or 10,000. Sorry guys, it's early. 10,000 equals 10 raised to what power? And the question mark is your answer in this case when you're trying to evaluate. So 10 to what power is 10,000? The answer is 4. So that question mark was a 4, so that's your answer. When you evaluate, this equals 4. It's kind of like saying what is 2 to the third? 2 to the third is 4. You're just saying what is this number? This number is the same as 4, right? So same thing here. If you want to go from log to exponential, you would get rid of the log. The base would go under the y. So the 10 would go under the y. Y pops up. So this is an exponential form. So your answer is essentially y, that value. 10 to what power is 0.01? It's -2, right? 10 to the -2nd power. So when you end up with fractions, it's usually because there's negative power, right? Because 1 over 10 squared or 1 over 100 would get you 0.01. So your answer, if you evaluate log base 10 of 0.01, is equal to -2, if you put that in your calculator. So same thing here when it says log base 2 of 8, what is that number, right? Equals to what number? You could do what I like to call the log bump. So you could set it equal to y. Oh my goodness. And then you would say 2 to what power is 8? And your answer is 3. So 3 is log base 2 of 8 is equivalent to 3. So same thing here. I like to just set it equal to y, and you're trying to solve for y. Y is the number. What does log base 9 of 3 equal? So we do what I like to call the log bump. Get rid of the log, bump the 9. I'm turning to exponential form. So 3 equals 9 goes under the y. Y is the value. So 9 to what power is 3? It's a half, right? 9 raised to the 1/2. Because remember, when your power is a fraction, you have a, m, n. And you can rewrite that as, sorry, this is really sloppy. Your index goes there. It's a to the m would go underneath. So you'd have the square root, because the n is a 2, of 9 to the first, right? And the square root of 9 is 3. Right? So since the square root of 9 is 3, this answer is 9 raised to the 1/2. So our answer is a half. So log base 9 of 3 is 1/2. Because they're saying 9 to what power is 3. Okay, when we look at the next one. So I'm saying, what is log base 6 of 1? So I bump the 6. And I'm saying 6 to what power is 1? 0. So my answer is just a number, because log base 6 of 1 is a value. So you're saying, what is that value equal to? It's equal to 0. Log base 8 of 8, I'm saying, what does that become? What's that value? And I like to do what I call the log bump. So we get rid of the log, we bump the 8 to the other side. graphs. So we bump to the 8 to the other side. Oh my goodness, this is annoying. Okay, you get the point. So you bump the 8 to the other side. 8 to a power is 8, and the answer is 1. So log base 8 of 8 is 1. Okay, so now if we're going in reverse and we want to convert these to exponential form. So here you see log form, and now we want to see exponential form. When you don't see log, you want logarithmic form. When you see log and you want exponential, you need to get rid of log. Okay, so if you're trying to isolate the variable, right, you want to know what x is. You want to think of it like this. You want to think of it as, okay, how do I isolate? The inverse operation is log, right? Exponentials and logs are inverses. Just like if we have multiplication, we know division is the inverse operation. If you're isolating this variable, multiplication, right, 2 times x, and division are inverse operations. So you'd say, okay, the answer, x equals 2. Now here, you're like, wait, I can't divide by 2, right? It's 2 raised to the x. So the x, the thing I'm trying to isolate or solve for, is a variable. And using logs and exponents, they're inverse operations. So what I would say is look at the side that the exponent's on. And in order to get rid of the 2, you would need to say log base 2. And what you do to one side, you do to the other. Log base 2. On the right, log base 2 of 2 cancels, so you're left with x. And on the left, you have log base 2 of 16. So this is going from what we call exponential to logarithmic. And that's all it says. It just says convert. If it said evaluate, you'd say 2 to a power 16, right? But we want to leave it like this. Which this is equivalent to 4, right? 2 to the 4th, so x also equals 4. Log base 2 of 16 is 4, right? 2 raised to a power 16. Now, when we look at this, it says, though, leave in logarithmic. So we want to leave as log base 2 of 16. I'm going to pause here. I'm going to make the next video. Then you're going to do your practice sheet.